Hey, this is Rob, and I'm going to show you some things about gears in Fusion 360. First thing is how do you create gears? Then the second thing will be how do you space them apart so that the teeth actually mesh properly. And I'll also show you how to put a few of them together to make something like a gear train. And then I'll show you how to make them actually turn and move in the right ratio so that they actually look like they're working on screen. And we'll do that using a motion link. So the first thing is how to create gears. There isn't a command. If you look around, you'll see there isn't a command for creating gears. There's no gear generator necessarily like there is in something like Autodesk Inventor. But we do have a couple other methods. One is to use an add-in that's part of Fusion 360. It's got a couple of quirks, maybe a bug, and but it works. And so I'll show you how to use that. First, I'll show you how to use the other method, which is to just insert from the McMaster-Carr catalog. So we just type in spur gears in the search field, and here we have a category for 14.5 degree pressure angle gears. So that is one characteristic of gears that we care about. Some others are the pitch diameter, which is really important. We're basically using that to determine how the gears mesh together. And then the outer diameter, which is the overall size of the gear from the end of one tooth to the end of the other side. Then the other important piece of information we need is the number of teeth. So this particular gear has 16 teeth, 0.5 inch pitch diameter, 0.56 inch overall outer diameter. I'll click on that part number, choose the CAD icon, and then as long as this says 3D step, I can hit save and it should import it as a component. So you see here in the browser, it's actually the name of that component is actually the McMaster part number. If I'm okay with where it's sitting, I can just hit OK here, and I'll right click and swipe up to repeat that command, and I'll do the same thing. Just type spur, choose that category, and this one will be 24 teeth, 0.75 inch pitch diameter, 0.81 outer diameter. I'll choose save, and it's created a second component. See a different part number here. I'll hit OK. So they're sitting on top of each other, and the first question is how can I get them to be spaced apart at the right distance? So I'll right click on that bigger gear and move it over a little bit. I could sort of eyeball it, but that would be a bad idea. So actually I'll cancel this first. I'm going to change my units to inches since everything so far in the catalog has been inches. And I'll do that same thing. Move. I'll drag it over, and I want this number to actually be some formula. That formula is pretty simple. It's just the pitch circle diameter of the first gear divided by 2 plus the pitch circle diameter of the other gear divided by 2. I'll hit OK. So you can see they're meshing properly here, and I think this may be a good time to show you actually if I activate that first component, the smaller gear, I can create a sketch on this gear face. And what I'll do is I'll hit C to create a center point circle. And for the diameter here, I'll put in the pitch circle diameter that we got from McMaster-Carr. I'll click, actually I'll make another circle too. So I'll hit C again, and this one will be the outer diameter that McMaster-Carr gave us. So you can see the outer diameter is I'll click on these two and make them construction lines. You can see the outer diameter is just what it said. It's kind of the edge of the gear. And then the pitch circle diameter is, you can see here, it's actually like where these two teeth touch is right at that, it meets right at that pitch circle. We don't need this. I just want to show you that as a demonstration. I'll hide those sketches and activate the root component again. And so now what we're interested in is how can I, maybe it's fine that these are parallel and just kind of horizontally, I just moved it over in the X axis, but maybe actually it's supposed to be up here, 45 degrees from where it is. So here, I'll show you how to do that. If you right click on it, hit move, and try and rotate it, obviously that's not exactly what we want. So I'll hit escape and do that again. What we need to do is to say it should rotate around this point. So I can hit set pivot here, and instead of trying to find the center point of this gear, which is a little tricky, I can just choose any of the circles of the gear. So that circle works as a pivot point, or a pivot, and then I'll hit the check mark here. That's really important. So once you're done setting the pivot point, that check mark's gone, you can rotate and you'll see that it's rotating around the gear and it's still the correct distance. So those gear teeth would mesh. And you can see if I make it 45 degrees off from where it was, those teeth still fit together, but if I do 40 degrees, they don't. Let's just leave it at 40 degrees and I'll show you how to fix that. So I'll hit OK, and what I can do is just rotate the smaller gear and put in that same number, 40 degrees. So now they look like they mesh again. So I think that's about it for showing you some of those details, the pitch circle and getting these to be spaced apart, and also how to put them at an angle. I'll hide these two so I can show you the other method of creating gears. You go to the add-ins menu, choose scripts and add-ins, and you can either find it under the scripts tab, which means if you were to click it, you can click any of the three. They're just written in 3 different languages, but they do the same things. If you hit run, it'll run that command. You'll see the dialog pop up and it'll create a gear, and then it'll disappear. If you choose add-ins instead, when you choose one of these add-ins and hit run, it actually sort of installs it and it stays running until you quit. So you can see here this little circular logo or icon means that it's actually running right now. So what that means is the add-in actually created a create spur gear menu command here. So I'll click on that. Diametral pitch was not one of the pieces of information that McMaster gave us. So, but I do have some of these other pieces of information. So let's try filling those in. So I know this was 14.5 degrees for the pressure angle. I know it was 16 teeth, and the gear thickness doesn't really matter here. One of the quirky things, okay, so there are a couple of things that aren't so great with this add-in. One is that you could put in a parameter here. So for example, pressure angle could be actually something called pressure angle if you created a user parameter with that value of 14.5 in it. But when you create the gear, it'll sort of respect those values. It'll create the gear using those user parameters. But if you go back and change those user parameters later, the gear won't change. So it's not really parametric. It's just allowing you to put those user parameters in here for that one-off creation of a gear. So that's, it would be great if that worked. It doesn't work. So the other thing is, for whatever reason, you can't put a user parameter here in for number of teeth. So that's a little annoying. So you have to put a number here. And then the final thing that I've found that's kind of tricky is that that this field, for whatever reason, diametral pitch, only accepts centimeters. And normally you can get around that by putting a value in here and then multiplying it times 1 centimeter, but that doesn't seem to work either. So the only thing I've found that works is to actually just put in an inch value and then multiply it times 2.54. So that's what I'm about to do. But first, the diametral pitch is not one of the values that we got from that table in McMaster's catalog. So how do we calculate it? And the way that we do that is the number of teeth divided by the diameter of the pitch circle. So that was 0.5, and I'll again multiply it times 2.54 to get centimeters. So this is the diametral pitch in centimeters. If I hit OK, it creates a gear. And if I unhide that McMaster one, you can see they're the same size. So that worked. I'll do the same thing again, create spur gear. And that bigger one still had 14.5 pressure angle. The number of teeth was 24. And then here, again, I'll have to say 24 divided by 0.75 times 2.54, and I'll hit OK. So there's my bigger gear, and if I unhide the McMaster gear, looks like they're the same. So that worked out. Now, if you look, I'll do the same thing I did before. I'll move this over, and I'll use the same distance, which is 0.5 divided by 2 plus 0.75 divided by 2. It's moved them apart, and they're the right distance apart, but these teeth don't look like they mesh. So, if I want it to look like they do, which I probably do, even though they are the correct distance apart and would in fact mesh if in real life, maybe this is a little unnerving to me to see them smashing into each other here. So all you have to do is rotate it, I think, by just 360 divided by the number of teeth in the smaller gear. And if I hit OK, then they look like they mesh now. I guess the last detail is, if I hide these two gears, if I were to just create a gear from the add-in, and I didn't know some of these values. It's worth knowing that you can calculate these. So one is how do we, okay, so let me say this another way. Let's say we just take the defaults here. I'll hit OK, and it creates a gear for me. So given so far, I've only got the diametral pitch, and I've got the number of teeth. So if I wanted to do this same thing that I did before and create a sketch, I'll activate this new component. I'll create a sketch, and I'll hit C to create a center point circle. Where's my where can I find my pitch circle, and where can I find my outer diameter circle? So that can be calculated, and to get the pitch circle, it's just the number of teeth divided by the diametral pitch, which was 7.62, I think, in that example. Oh, but we're in inches, aren't we? So I suppose I'll have to do the opposite here and maybe divide this by 2.54. Oop. Multiply by 2.54. So there's my pitch circle. Then we can create the outside diameter circle. So that's I'll hit C again to create another another center point circle, and the formula here is going to be n plus 2. Sorry, not n. I'm looking at the actual formula, but it's the number of teeth. So that was 24 divided by plus 2. 24 plus 2 divided by the diametral pitch, which was 7.62. Of course, we're back to this problem of it being in inches, so I'll just multiply that times 2.54. So there are my two circles that I might be interested in. So that's basically it. I just wanted to show you how you can find those values without actually having access to them from the McMaster-Carr, for example. So the last thing I want to show you is how to create a sort of gear train. And let's say that I want these two McMaster-Carr gears, but I actually want 4. So I'm going to make a copy here, and I will paste on the root component. I'll paste new. There's no reason why I'd want them to be linked to each other, so I just created it as a totally separate component. And I'll do the same thing here for the larger one. I'll copy, and then I'll right click on the root component, paste new, and I'll move that one over as well. So I just drag them over to be spaced apart. What I'd really like is for these two gears to be, and this is kind of arbitrary, but this is actually what I'm trying to do myself, so I'll give you the requirements. I want these two gears to be horizontally, they're going to be parallel to each other just like they are now, or on the same axis, this direction. And then between them will be these other two gears. So I've got a large gear, a small gear, another small gear, and then the large gear. So how do I do that? It's kind of tricky if you start moving them around, especially if you want to make a change to the orientation of any, let's say these smaller gears, you want to change where they are, then everything has to get moved again. It could get really complicated. So the system that I've come up with is kind of a workflow, I guess, for you can create a sketch and then base the position of these gears on the sketch. So let's give that a shot. I'm going to actually hide these gears that I've just made, and I'm just going to create a sketch. And this sketch, I'll create a center point circle with the C key. I'll create this one at the pitch circle size of the smaller gear. I'll do the same thing here for the other small gear. I'll do the same thing here, but for the bigger gear. And the same thing again for the other bigger gear. So I've got my 4 gears, and there are a couple things. First, I said that these need to be directly across from each other. So maybe what I'll do is create a line between them, between their center points. I'll click on it and hit X to make it a construction line, and I'll add this constraint by right-clicking. I'll add a horizontal constraint. So now they need to be kind of directly across from each other. I could also add a dimension here and say that this distance between them should be 1.5 inches, or let's go with 1.2 inches. Now, how do I get these other gears to kind of mesh properly? We've already said that the way to get gears to mesh is to have their pitch circles be tangent. So I'll click on that circle and that circle. I'll right click and say that they need to be tangent. I'll say, let me move it over, make that a little easier. I'll say that this circle and this circle, right click, they need to be tangent, and this circle need to be tangent. So I'm creating this gear train where this gear connects to this one, connects to this one, connects to this one. Now, if I start trying to move them around, you'll see they all stay together. So it could be that there are different orientations. Maybe the distance here in this case always has to stay the same. If I remove that dimension, you'll see that they have more options for the way that they move. Or another thing that we could do is we could add the outer circles here, so the outer diameters. So I'll click here and I'll say the outer diameter of this gear is I think 0.81. That came from McMaster. And I'll do the same thing here, 0.81. The outer diameter of these were 0.56. Well, I don't even need that. I'll undo. So I guess the point I was getting to was maybe you actually care in this case about the outer diameter and that you don't want the gears to extend past a certain rectangle, for example. So here's my rectangle. I could say that this should be tangent to the rectangle, and so should this side. So this way you can make sure, beyond the pitch circles, which determine how these gears actually mesh, you can also tell how far the gear actually extends in real life. So in this case, I want to make sure that the whole gear train lies within this rectangle, for example. And then, of course, I could add a dimension here so that really I only have 2.1 inches to work with. So now my gears all adjust, right? So that everything is still within that rectangle. So let's go back a couple steps. So I don't really care about this rectangle. I just want to show you that that's possible. I'll leave it there, and I just won't have the. I think maybe it's worth going back a couple steps to just get rid of the rectangle, and I'll get rid of the outer diameter circles too. The main thing we're concerned with here right now is just how can we get the gears to now match up with the this sketch that I've laid out. So I'll hit stop sketch. I'll turn on my gears that I made, and obviously they're not in the right place. So the way that I can do this now is to use the modify menu and choose align. I don't want to align components, which I think might be the default. This is a component, the gear is a component, but these sketch circles are not. So to include the sketch curves, I would have to choose this align bodies, sketches, and I don't know what the ellipse means there. I guess I don't know. but we are interested in aligning these bodies that are part of the component with these sketch curves. So what I'll do is I'll choose, and this can get a little tricky right now as far as selecting these things. I'll choose this component, and I'd like to choose its center. So I'll just hover over that circle. I'll choose it, and then I'll turn the sketch back on and say it should be aligned with that center point. Should be able to just keep doing the same thing. So that should be aligned with that, and this circle should be aligned here. Oh, it's possible that I didn't. Okay, so I've got a little problem in that I actually did a paste instead of a paste new, I think, for these gears. So they're connected to each other. I think rather than fix that, I'll just say that's the problem. And now you can see at least how, I guess I should fix it. So I'll go to modify align, and you'll get a second look at this now. So I'm aligning that with this. I'll hide the sketch so I can choose this circle and align that with this center point. I'll do the same thing out here. I'll align this center point of this circle with this sketch curve and the last one. So there you go. The teeth are not aligned, and I suppose that could be kind of tricky, But I think it's more important that these are spaced apart correctly. In my case, it is anyway. I'm not so interested in this. I think I would, at this point, just kind of fudge it so that they look like they're, I could rotate each of these gears so that they look like they're, the teeth are meshing. So, just playing around until I find the right values to make it look like they're meshing. And that way it would look better in the drawing. But really what I'm concerned with is the distance between these. Now, the nice thing is since those sketch curves weren't constrained in space, I can move them around. And in fact, I don't know if you know this, but even though I'm not in the sketch, I can move them around. So you'll see here, as I move them around, they still are maintaining those constraints, the tangent constraints. Of course, it would be great if that align command kept these two aligned. It doesn't, but it's not that hard to just go back and realign these. So I can show you that now. If we just go back to modify and align, I can choose this gear and realign it with that circle. You can see that I'd be able to adjust and move the gears around and not have a whole lot of calculating to do. So the very last thing I wanted to show you is how these gears can look like they're meshing. So in this case, you can see I've got two gears that I brought in from McMaster-Carr. I made it kind of a base for them with these axles sticking out, and I created revolute joints between this gear and that axle, this gear and that axle. If I right click and choose drive joints, normally this gear would just move on its own, but you can see it's causing the other one to move as well, and it's meshing correctly. So even though this gear is bigger than that gear. So if we look at this motion link, you can see how I did it, and so there's a formula here, right? Like basically for every 360 degrees of rotation in the smaller gear, this second gear should rotate less. This gear will be slower than that one because that's the nature of gears. So for every 360 degrees of rotation here, there should be less than 360 for the bigger one. So that means 360 times this fraction is going to be a fraction of 360, right? So the way that I got these values is, of course, the number of teeth in the small gear, number of teeth in the bigger gear. I didn't have to put in 1 degree here, so it's just basically 360 times, in parentheses, the teeth of the smaller gear divided by the teeth of the bigger gear, and you can see from the animation that they are moving at the right speeds. So this one on the left goes faster than the one on the right. And of course, if I don't click reverse, then they are not doing what gears do in real life. They're moving in the same direction. So I'll have to also choose reverse. That's about it. I think I've shown you everything that I've learned in the past couple days since we're trying to do some things with gears. Let me know if you have any questions or you think I should add anything. Maybe I can stick something onto the end of the video. Thanks. Good luck.